So, hello student, welcome back to this physics lecture, and in this lecture we will be talking about principle of superposition. Okay, so this is the topic of our last chapter, that is the chapter of wave. And first we need to understand that what does this superposition means. Okay, so superposition simply means that to put one thing on another thing. Here you can see that I am talking for the progressive harmonic waves. Okay, superposition principle I will be applying for progressive harmonic wave. And last time I told that progressive harmonic wave are the waves in which the amplitude during it when it proceeds, the amplitude does not change. Okay, it remains fixed. So here in principle of superposition, you can see the definition is written, and it says that two or more progressive wave travels simultaneously in a medium without affecting the motion of one another, then the resultant displacement of each particle of the medium at any instant is equals to the vector sum of the displacement produced by two waves separately. Okay, so here is the equation. This is the format of the equation for progressive harmonic wave that we know. Okay, so this is the y is equals to what? Y is the displacement parameter which happens in x direction at any instant of time, that is what? T. And x is the position of that particle about which, for which I am talking here. Okay, the displacement of that particle which is at x distance from the origin. Okay, while the wave propagate like this, okay, this is the direction of propagation and this is the displacement that we know, that is represented by y. Okay, so it varies from 0 to maximum amplitude a. Okay, that I told many times. So for any particle which is at x distance from the origin, this distance is known as x. This we can understand better by showing the figure. Okay, so at any instant, what is the displacement of that particle? Okay, that instant is t, and omega is the angular frequency of that wave. Okay, so this is the general format that we know for progressive harmonic wave, that y is equals to a into sine kx minus omega t, where a is the amplitude, k is the propagation constant. Okay, we will be talking about the propagation constant. So k is equals to the propagation constant. It is represented like in terms of wavelength. K is equals to 2 pi upon lambda. This is the formula for k. Okay, that I am using here for progressive harmonic wave. Remember. Okay, and this is the format of that displacement. So let there be another wave in the same sinusoidal format, and both are what? Both are moving simultaneously. दोनों ही एक साथ move कर रहे हैं. Okay, in the medium, and the phase difference in between. Okay, this represents the phase of the particle at that instant. Okay, so this is the phase of another particle of another wave, of another wave. This is the phase of another wave which is traveling like this only, and both the waves which superimpose. Both the wave we have to put over one another like that. Okay, so here k is the propagation constant for that wave, and x is the position of the particle similarly from origin. Okay, so let that wave be represented like this, and this is the y2, let us say, this is y1, let us say, and for x position from the origin at any instant of time t. Okay, this particle is somewhat lagging with respect to this particle, and that's why due to that lag, because phase stands for the direction and the position of that particle. Okay, phase determines the direction and position of the particle at some instant. Okay, at some instant, and let us say that now the particle is at x distance from the origin, but it is what? It is having some other direction of its movement. The position is same no matter, but the direction is somewhat else. In this case, let the particle be coming down. So in this case, let the particle be going up. Okay, at x position. Let the particle be going up at this x position. So that determines that it is lagging some phase with respect to the initial particle, with respect to the particle which is there in the initial wave. Okay, so this is the simple concept here. So in this case, according to superposition, the resultant wave will get formed, and the resultant wave will be having the same format. Let us see, it is having the same format or it is having some different format. Okay, so we have to get the displacement term of that particle which is at x distance from the point of propagation. Okay, so according to that, y will be equal to what? Y1 plus y2, and we simply use these two equations. Since the amplitude is same, okay, because for interference the amplitude should be what? Same. Okay, so here by taking a common in bracket we will be getting kx minus omega t plus sine of kx minus omega t plus phi. And you can see that this is the formula for sine A plus sine B. Okay, so the equation, the displacement equation will be coming like that: sine A plus B is equals to what? 2 sine A plus B by 2 and into cos A minus B by 2. So if I consider this to be A and if I consider this to be B term, therefore you can use the formula of sine A plus sine B. Okay, so let's use. So this will be giving 2 sine A plus B. That means this entire quantity will be added to this entire quantity. Okay, so how much you will be getting? Kx minus omega t plus phi upon 2. Okay, and into cos of A minus B, that means phi upon 2, minus phi upon 2 it will come. Okay, but since we know that cos minus theta will be equal to cos theta, so I am writing directly phi upon 2. Okay, so this is the format that which we are getting here, and you can see this format is very much similar to that of the displacement equation of progressive harmonic wave, that is equals to y a sine kx minus omega t. But here the amplitude is somewhat different. Okay, now if you rearrange this equation, then you will be getting a cos phi upon 2 into 2 sine kx minus omega t plus omega t plus phi upon 2. This is what you will be getting from here. Okay, that means this part is contributing towards the amplitude of the resulting wave. Okay, this is contributing to the amplitude of the resulting wave, and from here we can conclude that our wave is sinusoidal in nature. Okay, so this format is very much same to this format. Okay, you can see it is also a sinusoidal wave, but the amplitude in this case is not fixed. That means we cannot say that each particle is oscillating with same amplitude till end. Here the amplitude is depending upon the phi, that is the phase of that particle. Okay, so if the value of the phi will change, that means the value of this displacement equation will also get changed. That means the value of this entire amplitude will get changed. So when will the particle have the maximum amplitude? So the maximum amplitude will be there when the value of this cos phi upon 2 will become maximum, and we know that maximum value of cos theta is 1. So cos 90 if we talk, then it is 0, but if we are talking about cos 0, then we can say that it will be what? If we talk about cos 0, then it will be giving the maximum value, that is equals to 1. Okay, so for phi is equals to, let us say, pi. For phi is equals to pi, the amplitude will get what? For phi is equals to pi, the value of will become cos pi upon 2. Okay, that means in this case we will be getting what? Cos 90. Okay, in this case we will be getting cos 90. So cos 90 is what? We know that it is 0. So the amplitude term will be what? The displacement term will become 0 in that case. Okay, so when the value of phi will be equal to what? 0. So in that case we can say that here the y becomes minimum. Okay, here the y becomes minimum, but at this position it will be becoming what? It will be becoming what? Maximum. Okay, it will be becoming maximum because cos 0 is equals to 1. That means in that case the entire amplitude, if I talk, Okay, if I talk about the entire amplitude, then amplitude also behaves in the same way. Okay, so for phi is equals to 0, if the phase becomes what? For phase, if the phase becomes pi, that is equals to 180, then in that case I can write similarly that the value of A will become minimum, that is the amplitude. Okay, the net amplitude will become minimum. But here, or one can represent the amplitude by capital A for this resultant wave. Similarly, A will become maximum when the value of phi will be equal to what? 0. Okay, so that means the amplitude is not fixed. With the changing position, the value of the phi will also change. Okay, that means for the entire length of the string, if I am talking. Okay, if I am holding the string like this, in that I have generated two waves that has to be superimposed. Then in that case, a wave will be generated. A wave will be generated in the entire string, and that wave will be said to be a superimposed wave. Okay, that wave will be said to be superimposed wave, and that will be having the variable amplitude. That what I can conclude from here. Is it clear? So now let's talk about this conclusion graphically. Okay, so here you can see that the two waves are there. Okay, I have just placed one wave over another wave. Since these two waves, you can see they have same amplitude and they have same frequency. So we cannot distinguish one wave from another wave if I superimpose two waves. Okay, so they will be simply represented by this sinusoidal wave. Okay, here are two waves that I have to consider. Okay, both are lying on over one another, and you can see that the phi value is 0 because if there is any particle at x position from origin, okay, from origin, then for that particle will be going up for the first wave. Then for the another wave also, that particle has to go up, and that's why I have written that there is no change in the direction. Okay, there is no change in the direction, as well as there is no change in the position of that particle during its oscillation. And you can see that when phi is 0 in this case, then we will be getting what? The value cos 0, and cos 0 will be equal to 1, and we will be getting the value 2a, that is the maximum. If we increase this value of phi, then this entire amplitude term will be started decreasing. It will start decreasing. So here you can see that at phi is equals to 0, you are getting the maximum amplitude. Here you get the modulation in this entire figure. After superposition, it will modulate, and it will modulate as such that it will be giving the resultant wave of higher amplitude. Cos 0 will become 1, so the resultant amplitude will be 2a. You can see with respect to this origin, you are going 2a up, you are going 2a down. Okay, but when the value of phi will become pi, that means the particles are moving in opposite direction. Okay, here you can see at the point of intersection. Here you can see at the point of intersection where the two waves are intersecting. Okay, here you can see that the two waves are intersecting like this. One ray is shown by this dotted line, another wave is shown by this solid line. Okay, the two waves are intersecting one another. So here at any position x, one particle will have the tendency to go up just because of this one wave, and just because of another wave, the particle at that position will have the tendency to go down. That means both are moving in opposite direction. Okay, and that's why I have written for opposite direction movement of the particle at specific position, the value of phi will be equal to pi. And what you will observe in that? You will observe that the value by putting phi is equals to pi, you will get cos 90, and cos 90 will become 0. That means 2a into 0 will be equal to 0. So that means the net amplitude that we will be getting will be what? 0. That means the resultant wave is shown by this bold line, and it will have no amplitude in the vertical direction. Is it clear?